Angles and radian measure. We're going to start this first chapter of trigonometry learning about angles. And this diagram illustrates different parts of a central angle, and that's an angle whose vertex is at the center of a circle. Many times in trigonometry, Greek letters are used as variables for angles. And in the circle that you see here, the Greek letter theta is used for the central angle. The angle is made up of that flat horizontal side called the initial side, and it stays fixed, and then the other side goes around counterclockwise, and it's called the terminal side. Angles are measured in both degrees and radians. In a circle, the degree measure of a central angle is measured inside the angle itself, and the angle will be between 0 and 360 degrees. Radian measure depends upon the outside edge of the circle, which would be the arc, and the radius also. So the radian measure of an angle is between 0 and 2 pi. So you can see the arc is this outside edge, and the angle in radians is equal to the arc length divided by the radius. You won't really have to worry about that. It should be radians. We're just going to be able to right now go back and forth between degrees and radians. Angles are measured counterclockwise. If we measure them clockwise, then we make them negative. So if you look at the circle there, if I travel counterclockwise from one side of the angle to the other, that's 330 degrees. But if I go from one side to the other clockwise, that's only 30 degrees. Because I've gone clockwise, then I make it negative. So converting back and forth between degrees and radians, starting with degrees and going to radians, you multiply by pi over 180. So for example, if I want to convert 30 degrees to radians, I'm going to multiply by pi over 180, and we want to keep everything a fraction. We're not going to put these in the calculator and get a decimal answer. Remember, when you multiply fractions, you can reduce diagonally. So 30 goes into 180 60 times, and multiply across the top and bottom, and you end up with pi over, not 60 times, just 6 times, sorry. You end up with pi over 6 would be the radian equivalent to 30 degrees. Multiplying by 60, or rather converting 60, we multiply by pi over 180. Reducing diagonally, 60 goes into 180 3 times, so we have pi over 3 radians. If it's a negative angle, you still do it the same way. Multiply by pi over 180. And 90 goes into 180 twice. So we end up with negative pi over 2. And again, the negative just means we're traveling clockwise instead of counterclockwise. Now let's go the other way around. Radians to degrees, you multiply by 180 over pi. So pi over 3 radians, I want to change it to degrees. Multiply by 180 over pi. Then reducing diagonally, the pi's would cancel. 3 goes into 180 60 times, so it's 60 degrees. Make sure you put your little degree circle on there. Negative 4 pi over 3. Multiply by 180 over pi. Pi's are going to cancel. 3 goes into 180 60 times, so if I multiply across the top, I have negative 240 degrees. And one more. 2 pi, multiply by 180 over pi. The pi's cancel, and 2 times 180 is 360 degrees, which we said at the beginning that once around the circle is 360 degrees, and it's also 2 pi radians. Also be asked to convert between degrees and radians and give an answer rounded to 2 decimal places. That lets you know that you're going to be using your calculator on these. So 64 degrees converted to radians, I multiply by pi over 180. But put it all in your calculator and use the actual pi button. Don't do 3.14. So you're going to do 64 times pi divided by 180. and that gives you 1.12. Now going the other way around, we're starting with negative 2.35 radians. A lot of times if there's no pi involved, then they'll actually write the word radians so that it's clear that it's not degrees. You don't have to have that, and sometimes they put it, sometimes they don't. So negative 2.35 converted to degrees, we're going to multiply by 180 over pi. So negative 2.35 times 180 divided by pi is negative 134.65 degrees. Next, we're going to talk about coterminal angles. So suppose we've got a circle here. I've picked one that has some of the angles labeled to make our illustration a little bit easier. And say we start at 0 and travel to 45 degrees. So we've traveled a distance of 45 degrees. But what if we want to go to 45 degrees and then go around again and stop in the same place? Then we've traveled 45 plus 360, which is 405 degrees. And then say we decide to go around another time. So we've gone the 405 plus 360 more. Now we've traveled 765 degrees. But each time we've started and stopped at the exact same place. We've just gone around the circle a few times in between. So coterminal angles start and stop at the same place, no matter how many times you spin around the circle in between. That means 45, 405, and 765 are all coterminal angles. So what your homework's going to ask you to do, they'll give you something like the 765, and they want you to take it back to the 45, the smallest version of the angle, the one between 0 and 360. This is quick and easy to do. You'll just use your calculator. If your given angle is positive, then you're going to repeatedly subtract 360 until you've reached a value between 0 and 360. So if I have 2024 degrees, I'm going to subtract 360, and that's going to give me 1664. Subtract 360 again, 1304. And you don't have to write down this intermediate stuff. You can just keep going on your calculator. Subtract 360, 944. Again, and you get 584. One more time, and you get 224. This is where you'll stop, because you've landed on an angle that's in between 0 and 360. So you just keep on subtracting 360 until you hit that. If your given angle is negative, then you're going to repeatedly add 360 until you get between 0 and 360, or until you reach a positive value. So I have negative 922. When I add 360, I get negative 562. Add 360 again, negative 202, add 360 one more time, and now I'm at positive 158. So I hit a positive value, it's between 0 and 360, so that one is finished.